This is a part 2 of Unit 4. In this video, I will be speaking about the various tools which we are using in TQM. In the last lecture, I spoke about a couple of them. So this will be like a revision for that. So we categorize the tools into three different types. The tools for generating ideas, so it's called as the brainstorming tools, or the tools for organizing the data, and the tools for identifying the problems. So these are the three different types of tools in TQM. So in this case, for example, the tools for generating ideas, there are three different types of tools: the check sheets, the scatter diagrams, and cause and effect diagrams. So in this course, we will be focusing mostly on the cause and effect diagram, so which I called as a fishbone diagram in the last week, or a 4M analysis. And for organizing the data, you have your Pareto charts as well as your flow charts or process maps. So in the last week, we have seen the process maps and the tools for identifying problems. You have your histogram and statistical process control. So we are not studying in detail about these techniques. So let's quickly go through some of things. So let's think of an example. Assume that you ordered a pizza, and when you got the pizza, you opened it and found that there's some issue with it. So you're not satisfied with the pizza that you ordered online. So our focus is to find out the reason why you are not really happy about that particular pizza. So you can use different tools for analyzing the reason for an unsatisfactory pizza. So we will be using in this example, say, cause effect diagram. We will be looking at check sheets, and we will also be seeing how the Pareto analysis can be used. The focus is to identify the root cause of the problem. So in if I understand, if I am the manager of the pizza shop which is giving this particular pizza, and I know that some of my customers are not satisfied with my product, with the way in which I am delivering the things. But if I don't know the root cause for the problem, I will not be able to take an action. So finding the root cause is one of the most important things which happen in any TQM technique. So going forward here, so let's say that first I will start with the check sheet, for example. And what I do is at each hour, for example, my shop is open from, say, 9 o'clock till 5 o'clock. Let's say it's the 8-hour duration is what we are discussing. And if I categorize the different defects which can happen in, say, pizza. So the first defect could be that the pizza arrived was not in a proper package. So defect A could refer to the package issue. Now defect B, let's say it is referring to the pizza having or has got become really cold, for example, can be considered as a second reason. Defect C, let's say a wrong order has been delivered, for instance. So you ordered a certain veggie pizza and you got a different type of pizza at your place. So I try to categorize the different defects into, say, defect A, B, C, and so on. And I try to find out the number of times these defects are happening each hour. For example, it appears to me that defect A is maximum during, say, hour 1 and hour 7. So I can try to find out why. So my defect A was the packaging was not proper. So I can try to find out why the packaging was not proper during, say, hour 1 and hour 7. But all the other times the packaging was okay. So the hour 3 was the best one, wherein there was no issue with the packaging. So I can try to find out why there was no issue with packaging during hour 3, and I can try to replicate that same thing in all the other parts of my operating hours. Same way, for example, if you see here, The defect C, I said, let's see, giving a wrong order is, so I placed an order for a certain thing, I got a wrong pizza delivered to me. Let's say if that's called as defect C, I find that the defect C is maximum during the 8th hour. So what it means is towards the end of the day, the chances of having like order mismatch is very very high. So I can take an action. It is possibly because I don't have many employees and I get lots of customer orders during that particular time. So if I have a check sheet, I will be able to find out the root causes. The second method is called as is scatter diagram. Scatter diagram is a typical XY axis thing wherein you normally represent, see, an independent variable. So the X variable is generally an independent variable and the Y variable is always a dependent variable. So I try to see if there is any relationship between, say, productivity and absenteeism. So I find that as absenteeism is more, that means less number of employees are available at my factory, so my productivity reduces. So this is another way of identifying the relationship between the variables, say productivity and absenteeism. Now, going forward, so for your examination, last time I mentioned about it, what is important is a cause effect diagram, or it's sometimes called as a fishbone diagram, or it's an Ishikawa diagram, or it's even called as a 4M analysis. So in this case, they have written five of them. So we will not be looking at the measurement. We are not looking, so measurement can also be used, but we are not focusing on that. Our focus is always on the man, machinery, materials, and methods. So we try to put these four aspects and try to identify why a certain reason has happened. So I always said the effect has all to be put on the right hand side. The effect is the first thing which you need to put. Once you put in the effect, then you will be making a fishbone like this. We will be including man, machine, materials, and methods, and we'll try to find out at least one cause per under each of these particular things. So last time I spoke about the example of a student failing in an examination. We try to analyze the reasons for that particular thing. So this is very important. So this is another example of when you are, see, you're trying to throw in a shooting process, for example, you're trying to find out the reasons for missed free throws. You try to categorize them into man, machine, material, and methods. So in the case of shooting, the man refers to the person who is involved in shooting. So what we try to say is the person doesn't have necessary training, or he doesn't have a motivation to do it, or he lacks concentration. The machine in that case could refer to the method with which you are trying to aim the thing. So whether the rim is of a properly aligned, whether there is an issue with the rim size, you're trying to analyze. Method is the shooting process in itself. Maybe the position, the hand position is not appropriate, or the knees are bent. And the material is the size of the ball with which you're trying to throw the things. So you categorize. So what is important for us to understand is we need to understand that we need to categorize them into four different categories: man, machine, material, and methods. We need to put at least one cause under each of these. Now, the next method, this is also very important for your midterm. This is called as a Pareto chart. I will be doing a couple of examples on our Thursday's lecture, but let's try to understand how to make a Pareto chart. So Pareto chart finally, so after doing a little bit of data analysis, it looks like this particular thing. Let's see how to get this particular chart. So assume that you are the manager of Hard Rock Cafe and you find that there has been complaints coming from the customers. So you try to divide the different. So for example, this is a there's a data collection. It's a quantitative method. Quantitative means we try to do some data analysis and we try to find out the occurrences, the number of times each of these issues have happened. So when you try to look at the total complaints, let's say the different reasons for the complaints are the issues with respect to the pool hours, with respect to minibar, check-in times, room service, and miscellaneous. So we find that there are say 4 complaints for the pool hours, 3 for minibar, 12 for check-in, 54 for the room service, which is the maximum reason, 2 is for miscellaneous. So the first thing is you have this particular data. The first step which you do is you try to arrange the data in the descending order of the occurrences. What it means is the room service will be written the first, then you will write the check-in, then you will be writing about the pool hours, then the minibar, and then the miscellaneous. So the first step, this is the step 1. So the step 1 is write the data in the descending order. So let's try to see. Is it written? No, it's not written here. So the first step is to write the data in the descending order. So this will be the first thing which will come up. The second is the check-in. The third is the pool hours. The fourth is the minibar. Fifth is the miscellaneous. So we write in that particular order. Now, the next column is we need to find out the contribution of each element. I will try to explain how that is calculated. So step 2 is find the percentage of individual contribution. What it means is, say if I try to add these things, so 4 plus 3 is 7, 7 plus 12 is 19, 19 plus 12, 19 plus 2 is 21. Now 21 plus 54 is 75. So my total here is 75. So there are 75 customer complaints. So the first step is arrange the data in the descending order. So let's say that I have arranged the data in the descending order. Second step is to find out the percentage of contribution of each of these reasons. What it means is I need to find out 54 divided by the total, which is 75. Multiply that by 100 percentage. If I multiply it by 100, I know that this is the percentage contribution of this particular thing. So this is into 100 percentage. So likewise, I find the percentage contribution of each item. So for example, for check-in, I need to find 12 divided by 75 into 100 percentage and so on. So I do this calculation for this divided by 75. For minibar, it is 3 divided by 75. Pool hours is 4 divided by 75. So this is the second step. So we first find out the percentage contribution of each of these items. Percentage contribution of each. This is the step 2. Now, step 3 is basically finding the cumulative total. This is the step 3 in this process. So what it means is, let's see, 54 divided by 75. If I do this particular thing, I get, let me find out how much is 54 divided by 75. So I get it as, see, 72 percentage. I get this as 72 percentage. When I do the individual contribution is 72 percentage. For the next thing, say for example, for check-in is 12 divided by 75, which is 16 percentage. My third thing is say 3 minibar is say 3 divided by 75, which is 4 percentage. The this is the step 2 is what I'm so showing. 4 divided by 75 would be say 5.3 percentage, and the last one is the miscellaneous, which is 2 divided by 75 is 2.67 percentage. So this is the step 2 of this. So in the step 2, I just find out the percentage contribution of each of these items. Now once I do this thing, so let me use another color here. So let's say this is the step 2. I find out the percentage contribution of each item. So it is 2.6 percentage, and this is 5.3 percentage. Now the third step is to find the sum of it. What it means is I need to have another column to show the sum of each of these. For example, the room service is 72 percentage, but the cumulative of room service and check-in will be 72 plus 12, which is 88 percentage. The cumulative of room service, check-in, and pool bars will add up to another number, and so on. So this way we add the things till 100 percentage. I will show this in our lecture. I'm not showing it here. And then we draw a graph similar to this. So all these bar charts, for example, represent the room services 72 percentage, the check-in issues, pool bar issues, and so on. And this line, what you have drawn here, represents the cumulative. So for example, for the room service, it is only 72 percentage, and when I go to say room service and check-in, it is 72 plus 16, which is this will be 88 percentage. And the next thing is 88 plus 5 is say 93 percentage. The next point is 93 plus 4 is this is 97 percentage. And finally you add up to 100 percentage. So this is how this graph is referred to as a Pareto chart. So for the exam, you will be asked to make a Pareto chart. So what you will be doing is, first step is you arrange the data in the descending order. So it's like room service, check-in, pool hours, minibar, and miss. This is the first step. Second step is find the individual contributions. So for room service, it is 54 divided by 75 multiplied by 100 percentage, and so on. So once you find the individual contribution of each of these, you can draw a bar chart shown like this. So you draw a bar chart as shown in the figure. Now on this axis, there are two y-axis here. This is the x-axis. This y-axis you will be showing the frequency, and this y-axis you will be showing the cumulative percentage. So you can draw in a sheet of paper. Now, once you draw that particular thing, you'll be drawing a line chart by adding the cumulative percentages. So this dot is representing to 72 percentage, and the next will be referring to 88 percentage. The next point is referring to 93, 97, and 100, and then draw it using a line. So this is all what you need to do for drawing a Pareto chart. In the exam, you will be allowed to draw it in a sheet of paper, and you can take a photo of that and upload it for the examination. Now, this is what is shown, how this particular graph is arrived at. So, Pareto chart, as the name indicates, it is generally called as 80-20 rule. What it represents means is we are trying to find out the reasons which are contributing maximum to the issue we are discussing. So in the previous example, we can see that the maximum customer complaints are from the room service. So if I want to improve or reduce the number of customer complaints, I need to focus on the room service. The focus is first should be first on the room service before any other thing. So 80-20 basically refer to that. It means 80% of the time should be spent on the 20% of the task. But if you're not focusing on those important tasks, the chances are high that you will not be in business for long. So this is a very interesting principle called as a Pareto principle. The next method is called as a process map or a flow chart, which we have already seen in the last week. I took the example of you going to see Tim Hortons and buying a cup of coffee. When you try to do this thing, so we put each of these activities that make up the process, we draw it in the form of a simple flow chart. So even this, you can draw in a sheet of paper and then upload it in your eConestuga. So for example, this is a very complicated process map which you will not be expected to make. You just need to make step 1, step 2, step 3, step 4 and step 5, just 5 steps in the process map. And you can try to find out a couple of things. You can find out, say, productivity, efficiency, etc. from the data. So, and we also discussed something called as a cycle time last week. So cycle time is the total time it takes to complete any process. So last time we discussed about the time it takes to travel from your home to, say, getting the cup of coffee from Tim Hortons. If we define that as the process, it's consisted of 5 different stages, and we added up all the times to get the cycle time. We also discussed something called as a percentage value added time. So to understand the percentage value added time, what we did was we first looked at the process, analyzed the times where you are wasting. Basically, either you're waiting or you're doing something which is like a waste. You try to remove the wasted time to get the value added time. So this is something which we discussed in the last week. So the total elapsed time required to complete a business from start to finish is referred to as the cycle time. But in a cycle time, you will have value added activities and non value added activities. So non value added activities are typically the activities where you are waiting for a certain thing to happen. So we can calculate the percentage value added time using this particular formula. So there are some examples here. We took the examples last week. So I'm not discussing much. So for example, we produced 12 paper planes in 8 hours. So the productivity per labor hour is 12 divided by 8. So the first A is 12 by 8 is the answer for it. And it is asking what is the standard cycle time. So if the standard is 15 airplanes in 8 hours, so for making one airplane, so I will be spending how many minutes, which is 8 divided by, correct? So, sorry. So for making one airplane, I will be spending, say, 15 airplanes I make in 8 hours. That means one airplane as a standard value. So one airplane can be made in 8 divided by 15 hours. Now 1 hour is 60 minutes. If I multiply that by 60 minutes, I get it as, so 15 times 4 is 60, so I get it as 32 minutes. So 32 minutes is my cycle time. So the answer B is 32 minutes. Now calculate the efficiency. Efficiency is defined as, you see here, there is an equation given for efficiency. So efficiency was defined as the actual output divided by the standard output. So the actual output is 12 and the standard output is 15. So it is 12 divided by 15 is the answer for the efficiency. Now D is saying that, okay, my value added time is only 24 minutes, but my cycle time is 32 minutes. Find the percentage value at a time, which will be 24 divided by 32 multiplied by 100 percentage. So these things can come for your midterm examination. You'll be asked to sometimes draw a process flow map, which you can easily make. You'll be asked to find out the cycle time. You may be asked to find out the value added time and the percentage value added time. So this is one of the examples. I'm not doing the next example. Now we can always ask what's the percentage value added time, what's the cycle time, and so on. Now these are the three tools, as I said, the Pareto analysis, the cost effect analysis, as well as your value added time, this process map. These three things will be there for the midterm exam. And there are some more tools called as the histogram, which you can do. Another example is called as SPC, or statistical process control, which we are not studying here. In an SPC analysis, you will be having two limits, lower control limit and an upper control limit. And you will try to check if your data points are lying within these two, say, boundaries. If the numbers are not falling within these two, that means there is something wrong with the process. Now, we speak a little bit on the inspection. So we spoke in quality. You need to, whenever you have a quality team involved in the process, they will be checking whether the things are in a good shape or not. So the first thing is, if you are trying to incorporate quality systems or quality procedures in your manufacturing process, you need to make sure that there's an inspection process to check whether the product is good or bad, and it has to be inexpensive. If the process is very expensive, it doesn't make sense. So what normally is done is what is called as a pokayoke, or foolproof. So one example is source inspection is always the best. What it means is, at each stage of the process, you actually check whether, so let's say that the mobile phone manufacturing example, and if there are 5 different stages involved in the manufacturing of a mobile phone, starting from the raw materials till the final output. Now it's always better to check at each stage of it, which is called as the source inspection. Starting from the raw material, check whether the materials are okay or not. If the materials are not okay, don't allow the material to be manufactured. If the things are good, make sure that it is processed. Now, after the first step in the process, you check the item which is being produced. If the thing is good, then only allow it to go to the next stage. If the things are not good, stop from going to the next stage. So source inspection is something called as this. Now, Pukayoke, or foolproofing, I will discuss a little bit on this. So what it basically means is, whatever way in which you try to make an item, you may create systems in your company so that even if a fool works on that particular thing, the fool will not be allowed to, will never allow even a bad material to enter the production. So foolproofing is basically, there are multiple examples given here. So let's try to see some of these examples. So in many of the elevators which you try to see, what will happen is they are equipped with an electric eye to prevent the door. So whenever you're trying to enter an elevator normally doesn't close. There is a way in which it checks whether a person is crossing the elevator. So this is an example of a pokayoke, and there are multiple other examples also given. The same way with a smoke detector. So in a smoke detectors thing, if you're not putting the battery, you cannot mount a smoke detector. This is another example of a pokayoke system. The same is the way with the anti-theft things which you are kept in, say, Walmart. if you purchase something and if you haven't paid for that particular thing, and if you try to leave that particular shop, it will start making sound. So these are examples of Pokayukis to ensure that the quality is practiced at each stage of the process. So there are multiple other examples as well. So Pokayuki normally refer to foolproofing. Now there are more examples here. So source inspection is always make sure that the Pokayuki is the concept to foolproof devices or techniques designed to pass. So only an acceptable product, only an acceptable thing reaches the customer. So you do things in such a way. Yeah, this is another example of, say, for example, in the case of when you are in an airport. So if you carry a really huge baggage, they say that you need to make sure that your baggage fits inside this particular thing if you want to carry it inside your cabin. So this is an example of a Pokayuki system and so on. Now the last thing is, how can TQM be applied in a service industry? Generally, as we have been discussing from the beginning, so in a service industry, measuring quality is very difficult. So think of an example which I have said. If you go to a restaurant, you and your friend visit a restaurant and order the same food and eat the same thing, at the end of eating and then coming out, when you're coming out, if I'm trying to ask you whether you like the food, one of you may say that this is the best food you have ever had, but the other person might say, oh yeah, this is an average, this is not a good place to be at. The reason is the way in which a person perceives is different. So it's totally perception based. So service quality is always more difficult to measure. There are perceptions which depend upon, say, your expectations. So you might have, so a friend who didn't like the restaurant had great expectations about it, but at the end it didn't happen. It can depend mostly on the perceptions. Now, how should you handle the, what are the various aspects of service quality? So certain things like, say, reliability, responsiveness, how quickly have you been served, whether there was an access, competence, courtesies, or whether the server was polite with you, whether the communication was proper, and so on. So there are multiple aspects which can affect the service quality. So as a result, service quality is very difficult compared to the product quality of a good. So with this, we are finishing this video. So in today's discussion, I started with 4.6, identify some of the tools and measurement techniques, and we discussed the importance of inspection and how EQM can be applied in services. So thank you so much.